Okay, so so we have quite a lot of tools in our hands now. So I'm just gonna quickly recapitulate. So we saw how we can use like atomic nodes, like text delays, blackboard set, blackboard ramps, OSC send, OSC receives, and we saw how we can integrate them and sort of into control structures like sequences, which like activates all the children one after the other, and selectors that activate them until one of them succeeds, and then parallel and simple parallel, which are sort of different approaches to running all the children in concurrently in parallel. Now, I want to go back a little bit to the selector now, because I mean I showed it earlier, but it probably didn't felt extremely exciting to you. So I'm just going to create one here, and basically what I said was that, okay, well, if you had a structure like this, I'm just going to deactivate the other ones just to show you. Okay, so okay, so now I only have this selector that's going to run. And so what it does is that if it succeeds on like as soon as it succeeds, basically it exits with a success. So it's only going to execute. So I have this situation here. If I run this, the selector runs for the first kid, which fails. Then it's going to go to the second one. The second one succeeds, so it's not even going to try executing the other one. Which is very different, of course, from a sequence, you know, where in this case the sequence will execute all the kids until one of them fails. And in this case, the first one fails, so it's not going to execute even the other ones. If I have a situation like this, it would execute the first one and fail in the second one. Okay, but back to the selector. I mean, okay, this is really cool. I hear you saying, like, this is really cool, but you know, well, how can I really use this? Like, this is like, you know, like, why would I have this kind of structure here? So selectors are usually used in combination with something else called they're a guard, or this has to do with conditions. So basically, usually what's going to happen when you as a selector is that you're going to want to attach some kind of check to say, okay, well, if this is happening, if this condition is true, then do the first node, and then do the first kid, and then like it should succeed, and otherwise try the other options. Okay. So in order to do this, so I'm just going to bring it. So I'm going to unselect this one and select this simple parallel node, just as a reminder. Okay. And I'm just going to bring back those two terminals, so you remember from the last tutorial that here we have this prioritized first kid that is constantly changing these values, but the two others, the OSC send and the OSC receive, always are repeated, okay, until this main node stops. So if I change here the value, it's gonna make the other one react. Okay. Now let's say that instead, if we go back into this, let's say here I have my OSC sends to BBVal dollar value, which is controlled by Blackboard RAM, times a sensor. Let's say instead that I have a sensor which only sends 0 or 1. Just going to reactivate this one. Only sends 0 or 1. And it's not that I want to multiply it. Let's say that instead I want to send a different message, okay, if the sensor value is at 0. So how could I do that? Well, I'm going to have to add some kind of a condition, okay? So here what I'm going to do is I'm going to copy paste the selector. I'm going to go Control X and select it, and Control V, okay? So it's just put it here, and then I'm just going to move it here. So so now you see your first example of a nested composite node. So I have a simple parallel. Inside the simple parallel, there's a selector node. Now what I'm gonna want, I'm gonna remove this. I'm gonna remove this. I'm gonna remove this. And I'm gonna put this OSC send here. Just gonna copy paste it. Okay. So what we're gonna do here, what we're gonna want is that if sensor is 1, then we'll want just to send the BB value. If it's not 1, then we'll just send something like error, let's say, or no sensor. Okay, just gonna send this message. Okay, so again, if the sensor value is 1, I want to this is prioritized. So if it's 1, I want this to happen. Otherwise, just BB no sensor. Okay. Okay, so let's see what happens. Now, of course, at this point, if I, you'll see that I have these values that are getting printed here. But if I change my sensor to 1, nothing really changes because this always succeeds. So the selector succeeds, so it's not going to even bother going there, right? That's what the selector does. So what I need to do is I need to add a condition check here. I need to check if sensor is 1, okay? And I'm going to do that by adding what is called a guard decorator. Okay, so this is like that. Just stick with me here. So I'm going to add a decorator to that node. So what is a decorator? I'm gonna come back to this, but for the time being, just imagine that the decorator is something that changes slightly the behavior of a node. I'm going to add a decorator. I'm going to add a guard decorator. Okay. And what I'm going to say in this guard decorator, I'm going to check if sensor equals 1, okay? That's what I'm going to check here, okay? So this here, if sensor is 1, it will go there. If it's not 1, it will fail, okay? So let's restart it. So you see that, I'm just going to pause it. So you see what happens here. My sensor value at this point is 0. So when I go, this gets executed in loop, and so the sensor value, because there's this decorator, since the sensor value is not 1, this fails. Because this fails, then we go to the second option, okay, and if I run it, you'll see that I have these no sensor messages that get printed, okay? Now let's see what happens if by using this mechanism, I change the sensor to 1. Then suddenly, this one now gets verified. So when at every step the selector goes, and it's like, oh, is sensor 1? Yes. Okay, well, I start printing the value. Okay, and I mean this can go on and on and on. So if I use any other value, and it's not just 1 or 0, any other. So let me set it. So any other value actually will prevent this from happening. Only 1 will work because I'm checking is it 1. Okay. So that's how usually you will use a selector, is in combination with guard condition. And of course you can have many of these guard conditions. Just gonna copy this, edit this. Let's say here I can have a sensor equals to do something else. Okay, I don't know, I'm just inventing stuff here just to make it clear. I'm gonna be sensor 2 here. Okay, so let's run this and let's see if I change my sensor to 1. I have this to 2. Then I have the second option, and to any other value. While the 2 first options are not going to be checked, and I'll resort to the third one.